Hey everybody, Mr. Bells here. I want to talk to you on this video about regular polygons and the areas that they take up, how many square centimeters, square inches, whatever, if you're only given one bit of information to begin with. Okay, so we're going to try and break these things down into how many triangles fit inside one of these things and use that formula. So we're going to start with this one right here, and we're going to say that this is a regular polygon. And the first one that I'm going to do is I'm going to give you this bit of information. I'm going to say that the perimeter of this thing is 100 centimeters. And it's my belief that if we know that we can find the area of this shape. Okay? So perimeter is 100 centimeters. We're trying to find the area, and we're going to go through this process. So the first thing that I'm going to need to do is I'm going to need to find out how long one of these sides is. So I'm going to count 1, 2, 3, 4, 5, 6. This happens to be a sixagon, or also known as a hexagon. But the fact that it has 6 different sides to it, okay? So the next thing that I'm going to do is I'm going to take this 100 and I'm going to divide it by 6. And if I do that, I turn my calculator on and do 100 divided by 6, you can see that I get 16.6 repeating. And that number I'm going to store in my calculator, or when I write it down, I want to type as many 6s as I can. So I'm going to go ahead and hit store, the STO button right down here at the bottom, store, and I'm going to store it in alpha S. Right there, representing a side, okay? And I know that on any of these regular polygons that they're made up into, again, if they're regular meaning all sides and angles are the same, made into 6 congruent triangles. So if I can find the area of one of the triangles, then I can find the area of the entire shape. Now I just found out this is a base. So if I can do this length right here, that goes straight down to this spot here, that's the height of triangle A, B, C. Then I can do the base, which is AC, times height, which is B down to here, times a half, and get the area formula for a triangle. So again, area of a triangle is equal to 1/2 base times height. Also in this class, I believe that most of you who are watching this should know that it's also 1/2 little a b, little a times little b times the sine of angle C, if you've used that formula before. Okay? So whichever one happens to work for you. So I'm going to use this one right here. I'm going to try and find this height. Well, the next thing that I have to know is I have to know how big one of these angles is in here. Okay? Well, 360 degrees to go all the way around, so one of those angles has to be 360 divided by 6, which is 60 degrees. And if that much is 60 degrees, then I must have a pair of 30-degree angles here. Okay? So now to find this green, if I put my little person here, right, looking at this angle, I would know that this side right here is my opposite, and this side right here is my adjacent. And opposite and adjacent is tangent. So I can write the tangent of that 30-degree angle is equal to the opposite side, which happens to be half of S, yes, half of S. So S was 16.6, what we had, right? Divide that by 2, I get 8.3 repeating. So this length is 8.3 repeating, and that's from there to there. That's that length. Because I'm using this right triangle in here, right? Triangle, let's call it BC, we'll call it F. So triangle BCF is the right triangle I'm using to to be able to find out this adjacent side. So tangent of 30 is equal to 8.3 repeating over my adjacent side, BF, which I just don't know how long that is. You know, right, that we take this and we switch their places. So segment BF is equal to 8.3 repeating over the tangent of 30. And remember, if you knew special right triangles, because we've already covered it at this point, you could just use special right triangles, feel comfortable with that. I just know that not everybody has been able to stay with that all the way through. So I got 8.3 divided by the tangent of 30, and I get 14.37. So my length right here is 14.37. So now my base is that side. My height is that 14.37, and I'm going to go ahead and store that in H. Store that in alpha H for the height of that triangle. And now I'm going to use this 1/2 base times height to get the area of this shape, and then multiply by 6 all the way around. So here we go. So 1/2, or 0.5, times alpha S for that side length, which is my base, times alpha H, which was my height there, and I get that. And that's the area of one of the triangles, and I times that by 6, and I get an area of the whole shape of 718.8. 718.8. What did I use here? Centimeters? So square centimeters. So that means there's, if the whole thing's 100 centimeters around, there's like 718 of those little things that can fit inside here, square centimeters, if that was 1 centimeter by 1 centimeter squared. Okay? So I'm going to go ahead and do another one right now. I'm going to do this in this section. Let's say that I had an octagon, a regular octagon, and this time I told you that the regular octagon had a length right here from the center to one of the edges of 10 centimeters. Now, last time, right, I gave you this length out here of X. This time I'm giving you the length from the center to an edge, which means that this is also 10 centimeters, yes? And if I wanted to find the area of one of these triangles, knowing since it's an octagon there are 8 of these things, I need to do 8 times the area of one of those triangles. Well, this one's going to actually be super, super easy if I have that length, right? Last time I had this length. This time I have this length. So, okay, let's see what we can do with this. So I believe that we know that the area of this triangle right here, I could do base times height, which I don't know either one of those numbers, but I can also say that the area is equal to 1/2 side A, 10, times side B, 10, times the sine of the included angle. Now, we're thinking, well, what the heck is this angle? Well, there's 360 degrees that go all the way around. This has 8 of these. 1, 2, 3, 4, 5, 6, 7, 8 of these angles that go all the way around. So I simply do 360 divided by 8 on 360 divided by 8. I get 45 degrees. So that angle is 45 degrees. So the area of that triangle is 1/2 A times B times the sine of 45. That's another formula we have for area. So I'm going to go ahead and put this in here. Clear 0.5 times 10 times 10 times the sine of 45 degrees. Enter. That's the area of one of those triangles, and I times that by 8 because there were 8 of those triangles. and the area of this regular octagon, area equals 282.84 square centimeters. Okay, so I've showed you one where I gave you the distances around the outside. I've showed you one where I give you a length on the inside. And I don't want you to confuse them because those are two different lengths. And with those two different lengths, we did two different situations. So now I go here, and let's do this one. Let's do a pentagon, or let's go pentagon, or something that has 5 sides. Okay, so if I'm doing this pentagon, then this time I'm not going to give you X. I'm not even going to give you Y. This time I'm going to give you Z. I'm going to give you this length right here. And from this length right here, we're going to see if we can find the area again of this figure. So, one more time. I'm hoping that you see that there are 5 different triangles. This triangle down here on the bottom, A, B, C, has been split in half to get us a right angle. So let's say that Z equals 4 centimeters. That by definition is called an apothem, a distance from the center to the edge. And we're going to try and use that in order to be able to find out how long this is right here. Because if I can do that, then I'll have my height, and then I can just double that to get my base, and I'll be okay. Okay? So I'm going to put my theta in here. This side right here is opposite. This side right here is 4 centimeters. And that's adjacent. So I'm going to use opposite and adjacent. I'm going to use tangent. So the tangent of that angle is equal to the opposite, which is unknown right here. Let's put that as a DC. So opposite DC, segment DC, I don't know how long that is, over 4. So the question is, how big is this angle? Well, I know that this angle, and this angle, and this angle, and this angle, and this angle all have to be the same. So I'm going to do this. I'm going to do 360 divided by 5. And I found out that each of those angles is 72 degrees, which means that this one, which is only half of that 72 degrees, must be 36 degrees. And now I can write that into my formula, 36 degrees. Now, my variable's upstairs. I'm going to leave it upstairs. I like it when it's upstairs. And I'm like, how do I solve this? Well, I have to multiply by 4 on both sides to get the DC by itself. So 4 times tangent 36, 4 times tangent of 36, I get 2.906. Now again, that's DC, that's this length. So I'm going to take that number and I'm going to times it by 2, and that is the base of that triangle. So I'm going to store that in alpha B for base. I'm going to put 4 stored in alpha A for apothem. That's the apothem. Good deal. And I know that I have area of that triangle is 1/2 the base times the height. So 1/2 5.8123 times the height 4, and that's one triangle, and I have to multiply that by 5 because on a pentagon there's 1, 2, 3, 4, 5 triangles. Okay, so here we go. 0.5 times the base alpha B times the height alpha A times 5 of those triangles in there. And I get the area of this thing to be 58.12. 58.12 square centimeters. Okay, and that that should be how to find the area given a side length, given an apothem, or given that diagonal, in this case, down to a vertice. Hope this was beneficial. Take your time with it. Get one of the triangles, find the area of one of the triangles, and multiply by how many there are. And that way, if you know this, you should be able to handle any of the situations I'll give you. Take care.